In this chapter, we discuss the refraction of light and how lenses and optical instruments utilize this phenomenon. We start by defining the index of refraction. Consider a highly directional beam of light, such as that emanated from a laser. In vacuum, the beam travels in a straight line, and the speed of light is c, which is equal to 3.00 times 10 to the 8th meters per second. As far as we know, nothing can travel faster than the speed of light in vacuum. However, light can travel slower than it does in vacuum. For instance, when light travels through a material, such as glass, water, or air, the atoms in the material absorb, re-emit, and scatter the light, which slows it down to a value less than c. Here we see a laser beam that first travels in vacuum at speed c. When a different beam enters the glass, its speed reduces to a value less than c, and then returns to speed c when it re-enters vacuum. More revealing information is attained when the light impinges on the glass surface at some angle other than 90 degrees. First, the beam that misses the glass travels in a perfectly straight line. However, when a beam strikes the glass at some angle other than the normal, other things happen. First, generally there is a reflected beam, which is not shown here. We are more interested in the beam that passes into the glass. On first thought, one might expect that, since glass is transparent, the light beam would go straight through. That, however, is not what is observed. What is observed is that the light bends away from its original straight line path. This bending, either towards or away from the surface normal, is called refraction, and the bent beam is called the refracted beam. When the beam re-enters vacuum, or whatever medium surrounds the glass, it will bend back to its original angle with respect to the surface normal. In the case of a rectangular piece of glass with parallel faces, such as a window, the exiting beam will be parallel to the incident beam, but displaced by some amount. The degree of refraction, as well as the speed of light in a material, depends on a property of the material called the index of refraction. The index of refraction, n, of a material is the ratio of the speed c of light in vacuum to the speed v of light in the material, or n equals c divided by v. Since both c and v have units of meters per second, the index of refraction is a dimensionless quantity, just a number without units. In vacuum, v equals c, and the index of refraction for vacuum is equal to 1. In a medium other than vacuum, the speed v is always less than c, and therefore n is always greater than 1. N is only equal to 1 in vacuum. The table shows the indices of refraction for some materials. The first thing to note is that the index of refraction of air is very close to 1 with a value of 1.000293. This means that, for most purposes, we just take the index of refraction of air to be equal to 1, the same as that for vacuum. As a quick example, if we know the index of refraction of a material, we know the speed of light in that material. For instance, the index of refraction of diamond is n equals 2.419. The speed of light in diamond is then given by v equals c divided by n, which equals 3.00 times 10 to the 8th meters per second divided by 2.419. This is equal to 1.24 times 10 to the 8th meters per second. Finally, as we will learn in the next section, the index of refraction can be used to determine the angle of refraction for light that passes from one medium into another.